In this video, I introduce the MEND, method demonstration distillation for large language models. Method demonstration distillation is a distillation method which trains large language models to be distilled long demonstrations into concise vectors without retraining for new downstream tasks. In context learning, uses a large language model with demonstrations to generate outputs as shown here. However, the long demonstrations increase the computational overhead, especially the attention-based large language models impose time and memory complexity quadratically with the input length. To reduce the demonstration length, MEND trims the context by distilling demonstrations into concise vectors that are then used to promote large language models. Large language models act as students when prompted solely with distilled vectors, and as teachers when exposed to the full demonstrations. During the fine-tuning optimization, the teacher parameters are frozen and the gradients are back-propagated from a large language model to MEND module. Suppose that D is the concatenation of demonstrations. The teacher model uses the input X and the demonstration D to compute the conditional probability P for each label C, where capital C is the unique set of Y, as shown here. Where ED and EX embeddings of the demonstration D and the input X, respectively. Some special tokens are inserted into MEND input as placeholders for the demonstration distillation as shown here. The student uses the distillated vectors and input to generate outputs, and the outputs generated by the teacher serve as the ground truth to fine-tune the student model. This is the MEND module, this student module, and this teacher module. The goal of MEND fine-tuning is to use the distilled short vectors to prompt the student module to generate the same outputs as the teacher with the demonstrations D. The KL divergence assesses the difference between the two probability distributions as shown here. The MEND fine-tuning process includes two stages. Stage 1 is pre-training as shown here. To capture the general knowledge of distillation, MEND module is pre-trained on a dataset, and then the knowledge distillation approach is applied to pre-train MEND module. Step 2 is fine-tuning as shown here. The demonstrations D are fed into MEND, and then distilled vectors guide the student to generate the same outputs as the teacher. As shown here, this prediction loss. The phantom loss is defined by using prediction loss and the distillation loss, where lambda is a balance vector. For more details, please check with these references. Thank you. Bye.